Let's start over. You didn't hear any of that. This is the first time you've ever heard this. All right, today we're combining two different lessons. This is going to end it for the kind of lesson, at least the first lesson, Unit 2. So we're talking about the vertical line test, which allow us to figure out, is it a function? Okay, is it a function or a relation? Mainly, we're focusing on the function part because at this point, if it's not a function, it's a relation, and we're going to break that down. We're going to talk about domain a little bit more and function notation. Okay, so three different, somewhat related and have different parts to it. We just kind of throw them all into one lesson. So let's look at this first. Number one, test if it's a function. Is it a function? The way we do this is vertical line test. The vertical line test is making a line up and down vertically. And if it hits the function one time, the key, if it hits it once, it's a function. If it hits it twice or more times, it's not a function, it's a relation. So let's look at these couple options here. Let's have one like this. Just go ahead and label, make a real basic one. Let's do one like that. Let's do this kind of oblong, oval, ellipse. All right, so I'm going to use the laser here. Let's put it up here. All you have to do to test, is to see that one vertical line hits the graph at one point throughout the entire graph. How many points is it hitting for that black function there? Once? How about over here? Forget about the grid. The blue grid in the back is just our coordinate grid. I'm looking at this function right here. How about over here? Once. This is supposed to be once. It does kind of look vertical, so I'm going to change that a little bit. So this does keep on going. Okay. So all you have to do is put down a vertical line, and it has to work everywhere along the function, but vertical line hits it at one point. Yes, this is a function. Okay. FUNX, that's how I abbreviated function. All right. How about this function or relation? Which one is it? All right, if you're on your phone, get off your phone, please. All right, what do we have right here? How many times does it intersect? Once. Just once, so what are we going to call it? Function. It's that easy, guys. I promise. This little segment is just a little thing we have to cover. You can put vertical lines wherever you want. They're only going to hit it once. Hits it once. That might be confusing for some people. You don't have to do more than one. You just have to look and see, well, is there any weird spots where you need to check? That's good enough. There's one. Okay. How about this one? Tell your neighbor. All right. Let's see. All right, raise your hand up if you know Isabel. It's twice. Watch. All right, 1, 2. This one is a relation. This one's a function. But what if you said this? What if you said, well, what if I make my vertical line right here, and it just touches our ellipse at one point? Wouldn't I be able to say that's a function? No. Touched it once. Why is it not a function?
Because it still touches twice in other spots.
In other spots, it touches twice. It's kind of like an all or nothing. You can't have it where you're like, well, if I choose here, no, but you could have chose here and it hit twice. If there's any place it hits twice on the graph, relation. Hits once, function. Vertical line test, thumbs up, sideways down. Can we do that? You want to see another one real quick? Anybody? Crickets? No, because we got it. We can move on. Okay, good. I trust you. All right, here we go. This is nothing new. It's just a different notation for doing equations. I could have written this equation as y is equal to 2x plus 3. But when I'm using function notation, I just have a different way of expressing the y. And it helps us because it helps us remember what the heck we're doing. Okay? Because, well, one thing to point out, f of x. That's how we say this, f of x. F of x is not f times x. We are never solving for this x here. This is function notation. It is synonymous with y. It means and replaces y, but it just reminds us what we're plugging in for x. It reminds us what we're plugging in for x. So you see right here, if I have f of x equal to 2x plus 3, I bring it down here and I want to see what f of 2 is. And look what happens. Instead of 2x plus 3, it's 2 times 2 plus 3. So f of 2 is equal to 7. What did I do with that 2? My function is f of 2. So what did we do with the 2? Plugged it in for the x. That's all function notation is. It helps us remember and organize what we plugged in. So what I want you to do is find f of 4 for our same function. For f of x equal to 2x plus 3. F of 4, if you don't remember, tell your neighbor, what are we going to do with 4? What are we going to do with 4? Oh, excuse me. We are actually using this example, so we're using this function right here. This function right here, f of x equal to x squared plus 3. We need to find f of 4 for this function. So go ahead and do that. I kind of misled you. What goes there? 4. And then work it out. Right? Questions in the back? Questions? Bring them up. Just got to see it a couple times. Let's just do like a handful of these on that whiteboard real quick. But what am I plugging in here? It's f of 4. 4. F of 4 tells me that within the function I'm plugging in 4 for x. Now, my answer, I don't have to solve for f. Remember, this is function notation. It's not f times x. This is f of x, that's function notation. So in my answer, it's going to be f of 4 is equal to 4 squared is 16 plus 3, 19. I'd put that in as my answer. This also tells me, what did I plug in for x again? 4. So when 4 is my x value, what is my y value? 19. So we also have a point. Okay. Function notation just helps us organize the information. We'll learn next that we can put a function inside of a function. Ooh, can't wait for that, huh? You're like, wait a minute. You must be wrong. All right, how about this one? Let's do a few. All right, we got this function right here. Okay. How about this? F of x is equal to 1 over x plus 2x. All right. I want you to find it for f of 2, and I want you to find f of negative 1. Negative 1 might be trickier. So f of 2. What am I going to plug in for x when I have f of 2 function notation? Plug in 2. Okay. So function notation. This is not f times x. This is just function notation. It helps me. Hello? Okay. So this just reminds me we're plugging in 2. So we're going to go with 1 over 2 plus 2 times 2. What do we get for this? We get f of 2 is equal to, what's this right here? 4, right? 4 plus a half. I'll take the decimal any day. Mixed fractions, you don't really use those much anymore. So keep it as a decimal or an improper fraction, actually. Just this 2 and 1/2. To really use that, you got to make it improper anyway. All right, guys, go ahead and knock out f of negative 1. We got one of the answers. Just be careful. Just plug it in carefully. Looks like we're going to plug in something here. Okay. Knock it out quick. Okay, where's your paper?
You already did it. Mental math.
Put one more.
So mental math. So nobody remembers mental math the next day. Got to give yourself a clue. Kaden, what am I putting in for my x values? -1. We see how this is working? F of -1 is equal to, what's 1 divided by -1? And then what's 2 positive times -1?
-2.
-2. So we just figured out that f of -1 is equal to -3. This is the point. What did we plug in for x again? -1. What was my y value from that?
-3.
So we also can pull points out of this. This one here is 2, 4.5. So these are points. These are points. So, you know, it just helps you remember what you're doing. It gets more complicated as we add in, you know, functions inside functions and whatnot. All right. Thumbs up, sideways, down for these 2 topics so far. Can we do it? Okay, that's good. All right, we got one more. One more. You'll be glad this is the finale for today. You'll be glad. All right. So, here's the deal. The domain and range of points. Basically, which one is the domain talking about, x or y? Domain? X. Range? Y. So, if we had a really simple problem where we had, you know, this point right here at 1, 1, or let's say 1, 2, right here, 1, 2. If I just had one point, my domain, with these squiggly lines, the brackets here help us to know what the set of solutions is. So what is the domain for one point that is at 1, 2? Is there any piece of information for the x values? What is our x value? 1. So my domain, if I had 1 point, my domain would be 1. Because the only thing that I'm interested in is this point right here. The x values that are included at this point are 1, because that's our x value. What do you think the range is going to be? 2. So the range for this one would be 2. Everyone agree? Everyone see? We're only looking at 1 point. We're not looking at anything else on that grid. 1 point. So the x value is our domain. The y value would be our range if we have 1 point. What do you think is going to happen when we have multiple points? Look up here. Maybe the puzzle helps you. An example. We have a point 0, 2 and 4, 3. I put in 0 for the domain. I have one more I need to put in there. I put in 3 for the range. I have one more to put in there. Tell your partner what values go in those boxes. Good. Tired? You want to take a lap? Sure. Can you wait 3 minutes?
Yes.
All right, somebody help me out. Evelyn, help me out. Almost. Someone else help me out. Leah? A 4. Why did you choose a 4? Because domain is?
The x.
Here's my x. Here's the other x. Here's the y. Here's your other y. So what goes in here, Leah? Range is about y. Yeah? Are you sure?
Yeah.
Okay. All right, here's the next. This is the last bit we got to do. And then you can go on a little lap, wake up. Let's look at this. Find the domain of range from the graph below. I'm only interested in these points. I don't care about the line or function that would create, you know, what we can create with those points. I want you to fill in all the domain with commas in between. All the range, commas in between. Check with your neighbor. And then I'm going to have one person speak up about it. I always put them in ascending order, from least to greatest. Yeah, I didn't say that. Sorry. You see how this is in ascending order, from least to greatest? 0, then 4, 2, then 3. Let's put them all in ascending order. Okay. Because it's just asking what's included in the domain. The numbers included are easier to recognize if they're in order. Yes?
Is 1 0?
Oh, okay. This point is at 1, 0. Yeah. So mine's a little different. That might help. All right, start checking with your neighbor. If you're sleepy, tell your neighbor, hey, wake me up. And just shake it. Shake it.
Yeah. Why do you grab it? Oh, yeah.
Because the graph has 4 different points, so we gotta look at all of them.
I did get it.
All right, good talking. Keep talking. Make sure you. There you go. Really check if the other person has it. All right, Nate, you're gonna help me out. Make sure you got them right.
No.
Alright. Well, I'm gonna start asking folks. Well, no, I'll give you 10 more seconds. Yeah, it's always left to right, like we read left to right. It's always that. All right, let's see about this. All right, let's see. Jordan, help me out. What's the first value? Actually, tell me the points. What's this point?
That is, I didn't write out the points. I did.
-2 what?
-2 and 3.
There we go. What's this guy right here?
-1 1.
There you go. What's this one?
Is that a 0?
It's at 1 for x, and it's on the x-axis. So it's 1, 0. Okay. And then?
That is 2 -2.
You got it. All right. We got all the points. We know which one is x. It's the first one. Marcus, what's the first number you have in your domain? -2. We're just going in ascending order, so the lowest number first. Okay, let's see. Genevieve, help me out. What's the first range we're going to do?
The first range is -2.
Okay, as well, -2. So we're looking at this point. We've done that for the y. We've done that for the x. Let's do all the x's. That was probably a backwards way to do it. I'm going to take that out for a second. And we can put it. If you put it in there already, it's fine. I'm just going to start the same thing. All right, Kaden, help me out. What's the second value for our domain?
-1.
Okay, Quinn, what's next?
0.
0.
Or maybe 1.
1, because there's no actual 0 for x. That one is our y. Close, close. Loretta, what's the last domain value? 2 for x, right? So we just did these x values. All of those went into my domain. What do you think we should do for the range? Same idea, right? Same idea. So what is the lowest y we have? -2. The lowest y is going to be lower down. We're going to move up now. Okay. -2. Next.
0.
Next.
1.
Next.
3.
Got it. Yes.
Could you also do it with, like, for the x and the y to be like matching points? Like the first one would be matching points, the second one, or do you have to do it that way?
Do it this way, just because this is the this is the solution set. Okay, and within the solution set, it is it's not relating the values. It's just saying what x values are included. And if I wanted the most basic list of what's included, it's easier for me to see it if it's like least to greatest. So you could see what's not included easier. If those were jumbled around, it was like 1, -2, 2, -1. You see how it's just like a less organized what x values are involved. We're going for what x values are involved. That's a really good question. Thumbs up, sideways down for this. How are we with this? Oh, that's a lot of thumbs. That's good. All right, then you have, how much time? Oh, look at this. I gave you 22 minutes. We're going to do all the classwork. Let's get on it. Tables are open up there. Do we need to tell anybody at home? Do we need to tell anybody at home how to get a Kit Kat? Subscribe. Which number gets a Kit Kat? What are we not going to do? To then?
Subscribe.
That's right.